3D Systems is the most commonly well known as a provider of 3D printing machines. So 3D Systems invented the 3D printer about 35 or 40 years ago. And as computer-aided design technology has come along over the past 35 or 40 years, and 3D scanning and computing power have improved, we now it makes sense for 3D Systems to get involved naturally with software products to help design and create for general manufacturing or for prototyping. And part of that is very much the capturing solution, the capturing data and designing from it. And we're going to talk about scan-based design and inspection systems today. I'm going to blast through the PowerPoint real quick and try to focus more on the software as best as I can. So what we're going to talk about today is Geomagic Capture. It's the 3D scanner from 3D Systems. It's a structured light scanning system that's based on really well-proven 3D scanning technology. It's portable, professional, quality capturing solutions for your content creation. So a little bit more about Capture and scan-based design in general is that the Capture integrates the capturing of the data with the software application. So you can operate inside the software application with the Capture scanner, and we present a kind of combined solution that's seamless for quality control as well as design from scanned data. So, scan-based design is really great. It allows you to incorporate real-world objects into your scan or into your design. It allows you to improve your turnaround time on designs or mean time between iterations. It allows you to also get to a point where you can start designing. Many of our customers are designers that use reference surfaces to design their product, whether it's cell phone manufacturing or aftermarket automotive or aerospace. So what's really great, again, about the Capture scanner is that complexity starts to become free, so you don't have to worry about designing something that is in the physical world. You can actually just capture it and quickly redesign it. So it really helps you save time between design iterations. And of course, as we mentioned before, it's integrated and high-end professional technology right at your hands for a low cost. And at the very entry level, now these days actually we're offering the product for under this price. We have some new promotions out there for buying Geomagic Capture with our wrap software. Very attractively priced to be able to get both for under 15 grand. So what 3D Systems has always done in the past is take really high-end professional technology and try to combine it with other products for a total solution that's less expensive and almost just as good as the really expensive stuff. So taking that professional and production style technology and bringing it to your desktop or bring it to your home. So typically 3D scanning has been a really expensive proposition where you've looked at $50,000, $60,000, $70,000, $80,000 scanners, even $200,000 scanners, and then on top of that you got to buy software. So I'm sure if you're here you've probably gotten a 3D scanner demo or many 3D scanner demos in the past, and you're familiar with the pricing structure. And those more expensive scanners are still very awesome, and they have a great place, and they have really great accuracy, and they're just different for different tools. But what we're trying to do is make it so that if you try to reach out and get that technology in the past, you can get really close to it with an affordable and professional solution that's combined with software. So together, I think our highest priced product with software and scanning is less than $30,000, which is pretty attainable for a lot of software or a lot of companies. So we've got a bunch of different ways you can use the Capture. You can use it as a plugin into CAD software, or you can use it as a standalone application. You can use it as a plugin inside SOLIDWORKS and SpaceClaim right now. So SOLIDWORKS and SpaceClaim both have the same or similar kind of design functions inside the plugin, so that the plugin is pretty much identical between the two. And that's great because it allows you to leverage your existing CAD system to start incorporating scans into your design. And then if you have some more kind of heavy-duty needs for 3D scanning, let's say you already own a scanner, or maybe you already own Design X, or maybe you're already a customer, you can use the Capture scanner if you're up-to-date to maintenance. So if you are up-to-date in your software maintenance, our software includes the Capture plugin. So you can just plug the scanner right in and start working. So Design X would be our most kind of high-end reverse engineering software for surface modeling, automatic and manual solid creation feature-based modeling. And what DesignX is so good at is it allows you to treat scan and CAD data as equals and kind of interchange between the two and convert scans to feature-based CAD, which you can then live transfer out to your feature-based solid modeling programs like NX, SolidWorks, Inventor, and Pro-E. And then the other option that we have is you can actually buy Capture for Design Direct, which is our SpaceClaim Plus Capture plugin, so you can buy them both together as a complete system if you're looking for a direct modeling system. So let's also chat quickly about Capture for our inspection products. So the scanner is actually fairly accurate. I mean, with our BDI, BDE testing, we're at 60 microns, and that's just a little over 2,000. It's great for a lot of applications. For a lot of other applications, it's not, but 60 microns is pretty good for some general purpose inspection. So it's actually very fast, very accurate. It's portable and shareable. So instead of having to, if you're a designer, and you have some parts coming from a supplier, or your machine shop makes some parts for you and they come back, you get a prototype. Instead of having to go trot down to the guy at the CMM and have your part wait in line for days behind others, if the CMM guy's very busy, you can do it right at your desk. So you get this very accurate, state-of-the-art technology at your desk or your local surface plate. And again, very affordable price. We've got Capture as an add-on to our inspection software starting around just 20 grand. So we have two inspection softwares. One is called Geomagic Verify and one is called Geomagic Control. Both of them are legacy rapid form and Geomagic products, and some may have one or the other. But Verify is great for CAD-based and extensive GD&T tolerancing for your part. So it's very easy to quickly create kind of a detailed first article inspection. And Geomagic Control is great for automatic inspection and kind of rapid analysis of data sets that don't require human interaction. So there's an extensive scripting interface that's extensible to other functions and libraries inside Geomagic Foundation products that allow you to kind of create your own program to operate with scan data. And that's really cool. It's really flexible. So again, in the end, who better to get involved in 3D scanning and 3D scan data processing than the two folks who've been really the preeminent and the kind of the primary people in the world for processing 3D scan data. With 40 years of combined experience between Geomagic and Rapid Form, we've got just unparalleled experience. And we want to make sure that our customers are still using those really high-end systems, but we also want to provide you with a kind of an entry-level solution so that you can just get started, get up and running, and make this more affordable and obtainable, just like 3D Systems has always done, is take that professional technology and bring it to the consumer. So today we're mostly going to talk about Geomagic DesignX, and DesignX is a feature-based reverse engineering program. What I'll do first is I'm going to connect to the scanner, and we'll take some scans. So I go to Scanner Direct Control, connect to Geomagic Capture, say OK. So Geomagic DesignX functions with all different types of portable metrology devices, and of course, now we have just this great interface for the Geomagic Capture scanner, and it's just going to get better and better with every software release. I am on the road, so I don't have a webcam, but I'd love to show you how things scan. So what's great about the Capture is that I can show you through the eye of the scanner what we're looking at. Now, what you can see is I've got the scanner set up just in front of my part. Now, actually, just to do a little adjustment, do kind of like that. And I can see the view out of one of my cameras. Now, with that, I've got two things I want to pay attention to. I've got this crosshair, which tells me if my part is centered. And then I've got the focusing pattern, which tells me whether the part is in focus. So I can see if this edge is sharp, then the scanner's at the right distance. So the standoff distance for the scanner is roughly about 0.3 meters, so 300 millimeters from the face of the scanner is the prime focus distance. And it's also a fixed field of view system too, so it's got a single volume that it's going to scan stuff inside. And at the front of the volume, you'll have more dense point data. At the back of the volume, you'll have less dense point data. But on average, if you just point the scanner at the wall and the whole volume's filled up, you get 1.3 million points per second. and the point spacing is on the order of about 150, 130 microns point to point for point spacing. So that's pretty high resolution, and it's very fast. So let's talk about the plugin. This is the same plugin for all of our software. You get the same plugin. So it's really nice that it's uniform across everything. I can increase this or decrease the size of this. And it's really simple. On this page, we have scanning tools. On the settings page, I've got connection tools. Now here, you don't really need to worry about much except for the fact that if I just want to do a lot of rapid scans, I can scan in low resolution. Or if I'm scanning like a casting or something like that that's very pitted and rough, if I scan in low resolution, then I'm going to get, of course, less data, but it'll be a smoother, more general surface. It'll be very accurate, but it still will be less information. If I need all the data I can get, I can scan at higher resolution, so the full resolution of the scanner, and you'll get obviously denser point cloud data. So the other thing we can take a look at is we can align scan to scan via target alignment. You'll see that I've got this demo part sitting on kind of a mouse pad or a little slippery pad, and we can scan based on the geometry and align based on the geometry of the part. But we can also align based on this target system. So I just threw a couple targets out to show you that we can do this. It's very common in structured light scanning to use targeting systems to make the scanning quicker and easier. And just a couple do a great job. So first we'll scan in targets, and we'll go back to best fit. So I'll say OK to go back to the scanning window. Now I've got 3 buttons here, and I have an exposure slider. The exposure slider, again, this works just like a camera. As I go way up in exposure, this is 175 milliseconds per capture. And then this is much faster capture, but I'm not getting any data. So every piece, every part has different optical compliance, we say. So it's this is optically compliant. It gives me a nice return on it. And at this exposure level, I get great information. But it's actually thresholding out the table because the table is too dark. It's a dark table. So let's say I have a table with, or a part with multiple materials. I can use my HDR imaging tool. So I have HDR enabled. What HDR imaging will do is it'll take 2 scans underneath my exposure level, 1 scan on it, and 2 scans over. So a total of 5 separate scans where the part and the scanner will have to stay completely stable. But with that, what you do is you get a very dense point cloud that is able to scan across multiple materials. So if you've got a part that's got red and white and blue and gray or black or whatever all next to each other, like a tennis shoe or something, or some consumer product, then that's the best one to use because each one reflects light differently. I'm going to turn that off because this is a really optically compliant part. High sensitivity is a great tool for really soft features, like let's say you've got some fabric or cloth or hair, or and going back to the shoe example, if I have some sort of really fine pattern in fabric, like a mesh, it actually captures that amazingly well. So it uses some additional patterns that it's going to project onto the part to sense that. I don't need that right now because we're looking pretty good. This is a pretty hard featured part. Now the last one is auto exposure. Let's say I have no idea what to set and I just want it to set it for me. I can just say auto exposure, and it's going to take 5 measurements and look to see roughly where the best kind of ratio of exposed to underexposed is going to be, and that's pretty good. So there's kind of a very forgiving zone here. I'll bring it down just a little bit because I want to try to threshold out the table, and we'll just go ahead and scan. So from the time I press scan to the time I get my first data is just a few seconds. Now the first time we scan, we'll get data. It takes a little bit longer for the data to get into our application, but after that, every subsequent scan is quite fast. There we go. There's our first scan. So now, since I have target alignment set, I can actually just move the part like this. Scan again. Scan's done. Once it stops saying scanning, I can actually move the part. There we go. Just move it one more time. Now, target alignment is going to do a really great job at automatically getting these together with larger ranges of motion. If I just want to use best fit alignment, I'll have to move and rotate the part a little bit slower. But if I use target alignment, I can move the part a lot more because it's able to see these targets as a kind of a constellation that it can tie back into. But what I will try to do is I'll try to force it so it doesn't fit something. and I'll show you in the end how we can fit data to each other. And that would be just the same process of if I want to align one side of a part to another side of a part. You can do a manual alignment between the two and pick some like areas and fit them together. Okay, so after this one, what we'll do is move to best fitting instead of target alignment. So this is very fast. As you can see, if I wasn't talking so much, I probably could have scanned the entire rotation, at least one entire rotation so far. I'm going to minimize this window so we can see more scan data. And all I'll do is I'm going to go back to settings, and I'm going to make it best fit instead of target alignment and say OK. Now I'll move the scanner a little bit or move the part a little bit, bring it a little closer and say scan. And it should best fit a line back to the existing data. And the more data we accumulate, the easier it's going to be because it's looking for that common geometry. And this part's very basic and very simple. The places where it's going to have the toughest time are when you have really flat surfaces without much detail. So if a ball or like a fender or like a hood or something like that on my car, those are going to be more difficult because you can't tell the difference between one surface and the other. Those would be more difficult to align. So that's where I would implement using targets. So we'll take just another scan or two, and then we'll talk about how modeling portion works. All right, great. So that's pretty much it. What we'll do is you can see how easy and quick it is to scan, how great the alignments worked out. Oh, what I do want to do is actually let's try to force it. Let's move the part a lot, move it kind of a lot like that, and trip it up. And we'll see if we can get the scanner to not align, and then we'll show how to align scans back to each other. All right, well, it ended up working. let's try one more and see if I can get it to trip up. Just one more second. All right, well, it worked. I couldn't make it not do it. Well, let's simulate what might happen. So the cool thing is that as soon as we leave Design X's Capture plugin, it immediately asks us whether we want to run the Mesh Buildup Wizard. The Mesh Buildup Wizard is a great 3 to 4 step process that allows you to get your scan data fine aligned or closely aligned to each other and then merged into one scan. Because right now we've got 5 or 6 scans that are all sitting on top of each other that need to be kind of tightened up. Need to be more close to each other. And then once we get to the next step, it'll flatten everything and put it in a good format for us to start modifying. But I'm going to actually skip over it because I want to do something different. So we would recommend using that in the future. But what I want to do is let's go ahead and I'm going to go and say Tools. I'm going to transform this last scan or two. I'm going to move it really far away. And we'll show what it looks like to kind of realign stuff. Put it something crazy like that. So let's say this is the other side of the part that I can't see, the other side of this part. Or this is just some misaligned scan. It's really easy for us to go ahead and align between scan data. So I'm going to use a tool called Local Based on Picked Point, and I'll select a range of scans to keep as my stationary object, and then I'll select a range, or just one scan, to be my moving object. And this is very simple. You don't have to be really precise about this. You just can click. I know that this and this and this are pretty good features to click because they're all facing different surfaces. And I'll come and do the same thing over here. 1, 2, 3, 4, 5. And you can see on my left-hand side, you can see the results, what it's getting close to. And now it's not perfect because I haven't accepted it yet. So I'll go ahead and accept it. And then after it completes the process, I can actually go even further and fine align, get the individual scans very, very close to each other, and do the same thing that the Mesh Buildup Wizard might have us do, except step by step with a little more control. So great, gives us our plus minus values, our accuracy with respect to the other scans, and obviously the accuracy is not fantastic because we haven't been fully aligned. The next thing I would probably do is go and select all of my scans into a fine alignment, and that would get this way down to under 50 micron difference between the two to get them fine aligned, global and fine aligned. That might take a few minutes, so what I would do is I'm going to go ahead and pull the proverbial pre-baked chicken out of the oven, and we'll talk about modeling. So let's imagine I've merged everything together, and I want to start modeling the part. So this is where we'll talk about the software. So this is, at the top left-hand corner here, this is our feature tree for modeling. So if you're a feature-based modeler and you've used software like ProE, NX, SolidWorks, or Inventor, you're familiar with the kind of modeling fundamentals of sketching, extruding, sweeping, and locking, and things like that. Well, we have all those basic tools inside DesignX, but we also have these really awesome automatic tools that we'll talk about to make that geometry automatically. But the point is that we'll give you features for free. We'll make features for you. So there's our feature tree. This is our model tree. This will allow me to turn stuff on and off. And up here on the top, this is our toolbar. And these bigger buttons are kind of like folders with tools inside them, so I can go into editing meshes. If I go click my mesh mode, it'll allow me to edit or create a new mesh. I can create region groups, which we'll talk about very soon, or generate sketches that I can then operate on with my solid model and tools. So if the end result or end goal here is that I want to make a feature-based solid model, what I need to do is start adding a layer of intelligence to the model. So our first step is we would use region grouping. We would go to region group, and we would have it automatically region group and segment out these little areas. And what you can tell here is that when I mouse over a feature like this sphere, you can see that there's a wireframe sphere fit to it. You can see that there's wireframe cylinders fit to these primitives or spheres here, and planes, freeform surfaces. All of these are primitive shapes that I can now directly use with my modeling. So it took something that was really unintelligent and just a blob of points and turn it into something that actually had some smarts to it. So now I can start modeling. So what I want to do is first make the basic net shape of this part. So what we can do is I'll turn on my planes and I'll take a look at my part here, and I will go ahead and say Mesh Sketch. Now with Mesh Sketch, it's going to allow me to select any one of these planes here. I can choose a side plane, bring it through my part, and you'll notice that as I drag, I'm getting the cross-section profile snap to my base plane. Well, what I want to do is make a solid that extrudes up and past and down to roughly right here at the bottom of the part. So I'll do Mesh Sketch, and I'll choose either my plane or my region group. Since region groups are also planes, come down to right here. Now this is a really basic shape. And when I accept this, it'll square me up to the part so I can look right down on it, right at the direction of the plane. Turn off my mesh, and you'll see that I've got this cross-section profile here. It's all pink. I can't do anything with this until I turn it to CAD. So we've got these tools here that allow me to fit line segments to my part, and then I can trim them together. Or what I can do is if I want to make it really easy for myself, I can choose Auto Sketch. So these are all of our sketching tools that allow you to do dimensioning, constraining, trimming, all that stuff you're used to using. And here's my auto sketch. It generated a sketch for me automatically. Now let's say I want to put a variable rate or put a radius on this edge. I can delete it, choose a fillet, and put a fillet in right there. And then I can also get control over this, so I can accept it, smart dimension it, and say 0.08 or 0.8 I think it was. So I have smart dimensioning capability. We'll throw maybe a smart dimension on here, from here to there. Well, that's an angular dimension, but smart dimensions are really straightforward to use. Let's do something like that. We'll say 130. Great. So now I can force my dimensions to be certain ways. Now, what I can also do here is check my accuracy analysis. So we have this idea of something called traceable reverse engineering. Now, since I forced a dimension here, I've got more error there. If I can say Control-Z, and to undo that deviation, I can come down and see that there's no error there, or less error there. So there's obviously two ways to model, design intent or as-built. And this is more of an as-built type of modeling because I'm trying to make it as accurate as possible. Now what I do want to do is make a little edit over here, get rid of some stuff I don't want. Make a little fillet on the corner. somewhere around there. Say OK. Now once I'm done with my 2D profile, I can back out of Mesh Sketch. And my profile is sitting on my base plane. This is all very familiar for most people for CAD. Now what's really cool is that if I turn on my region groups, I got two things I can do. Now that I have a sketch in my feature tree, all these solid and surface modeling tools have come alive. I can use them now. So I can actually do extrude a solid, and I can extrude it bidirectionally. So I can go up and down, and it actually looks pretty good for the place I want to go down to, 15 millimeters. I can extrude this up and past my surface, but I can also, using region groups, extrude directly to a surface. Now what it does, it saves me a little time because it's going to go and fit a region directly to this surface, and it's going to, fit a freeform surface directly to this and cut with it. What we'll do is I want to show you how we make freeform surfaces or mesh fit surfaces, so we'll just go ahead and extrude past it and cut with it. So I'll say OK. So now I've got this solid block that I've used a manual tool to create. We have these automatic tools, but we're building up to showing you the automatic tools. This is the kind of fallback tool. Any great modeling program's got a number of different ways you can do stuff, and this is one of the examples of ways you can do stuff. So I want to make a freeform surface to cut this top with, so I'll hide my solid I created, choose my region group, and choose Mesh Fit Surface. Now what Mesh Fit Surface is going to do is center the surface on the selection area, and it's going to give me some options on how accurate I want to make this. All right, so what I've done is created the surface that I'm going to trim with. So I'll go ahead and say I'm going to trim, or we'll use cut the tool, or use the tool on the target, select the bottom, and there we go. So what that gives us is this great kind of surface that we can use at the top for our part, and we've got a net-based shape that we can really work with. So now I'll quickly just use Mesh Sketch to show how to do an open profile, and we'll get rid of some of the stuff we don't want here. So I'll use this, and I'm going to just generate this feature by making a little radius and a bounding box. And then we'll trim it up, and then go ahead and send it to a cut. So that's great. Now this should be basically all the kind of stuff you're used to using inside CAD, except we're leveraging region groups and solids and surfaces all at the same time as mesh. Now some of this other stuff, like these primitives, we can fit really easily with our primitive fitting tool. So if I want to fit a primitive cylinder or sphere, I select the type of feature and say OK. Now you can see I just easily fit a sphere to the part. And some of these, while these are more basic, still the combination is the same, or the thought is the same. I can actually select a couple of region groups, and instead of fitting one primitive shape, I can fit a primitive or use a wizard to generate it. Now I know this is a revolution because I know it has the same axis. I can say revolve wizard. Oh, and I can say solid merge is my result. And when I go to the next step, it's going to generate a profile. It's going to generate a revolution. It's going to generate a vector, all the info I need. So when I accept it, you can see I'm now starting to rapidly create features from our fitting tools. So we'll do just one more feature, and then we'll go ahead and live transfer it over to SolidWorks. So we'll say, let's select a couple of these guys. Now, let's say you don't know what the part is or what the feature is. You can actually just select a couple of region groups and say, figure it out for me. So I'll go ahead and right-click, use our right-click tools, and instead of forcing it to be a revolution, I can actually force it to figure it out for me. So I'll say cut some material. Now what that's going to do is go find the appropriate wizard for the feature and generate it for us. So I went and found other region groups that would be helpful. I'll go ahead and say actually change it to merge. And it'll do very similar to the other operation over here, except I didn't have to know what it was. So now you can see the solid is actually starting to build very quickly. Now, what do I do with all these features when I'm done? How do I move these over to SolidWorks? Well, let me throw a fillet onto one of these edges, and we'll go forward. So I'll select this radius for that edge, and use the Estimate Radius from Mesh button, which will tell me automatically how good my fillet radius is. And accept it. Now, typically, we want to do a little accuracy check before we kick it downstream. So this tells me how good my features are as I'm modeling them. Now, if I'm happy or I can accept that level of accuracy, I can either save this out as step, IGES, Parasolid, or whatever I want. But I can also live transfer this over to SolidWorks. Let's go live transfer my features to SolidWorks. Say OK. So what that's going to do is go bring up SolidWorks and start transferring our features one by one. And this is really the coolest part of the entire process. So it opens up a new file, starts creating sketch entities, brings over my features, and in some cases we have some issues when we transfer over, and it's easy to go ahead and fix. So what I can do is say surface. We'll go ahead and extend my surface. Let's go ahead and extend surface right there. Turn this over. I'll say extend surface right there. We'll say OK. Let's go ahead and extend it a little bit more. Now, this is actually a good exercise because sometimes, live transfers aren't always perfect, and it's really easy to actually just fix something and continue the transfer. So there we go. The surface looks good to me. Now I can say, I can go ahead and say, cut the surface. So I'm going to cut that. Cut the surface. Cut that body. Oh, did it backwards. Let's go ahead and go back here and roll forward a little bit. I'm going to undo, roll forward, and we'll say extend one more time. Here, there, there, and there. Say OK. Cut. I'm going to flip it the opposite way. Say OK. There we go. And now I can go back to my Design X and roll forward to about here, because that's where we can pick up. Say File, Live Transfer to SolidWorks, and then just resume from where I left off. And if I say OK, it'll go back over to SolidWorks and continue to reconstruct stuff. So that's perfectly fine. It's perfectly fine. So as you can see, we get some fairly straightforward live transferring tools that bring our parts and our files on over to SolidWorks with the features intact. So let me go ahead and hide the surface for you. Let's go ahead and hide it. You can see our part as we created over here. So with that, I'm going to go ahead and pass it back over to Hannah. And if you guys have any questions, we're here to answer it.
You can contact our lovely sales assistant, Marlene, to schedule a visit here at Q+ Labs, or we can schedule a convenient one-on-one webinar. Thank you all for attending our webinar today. I'd like to open the floor up to any questions you may have.
One of the questions I think I saw was for Scott, what's the biggest part that can be scanned?
Normally, we say that you should scan, or you can scan things that are roughly the size of half your fist, about the size of half your fist, up to about 18 inches cubed. So you can scan, larger stuff, but then you're only taking so much data. You have so many pictures basically you're putting together. It's an exercise in data management. So it's convenient to scan stuff about 18 inches cubed down to about the size of your fist. That's a good question.
The other one that we have is how long does it take to learn the software?
That's a good question too. If you're a CAD user already, it takes significantly less time than if you're completely new to everything. In general, we offer a 3-day training class at one of our training centers. And if you're a CAD user already, like I said, you're just learning the scanning part and the mesh part. So yeah, training is 3 days, and you pick it up faster if you already have a little CAD experience.
What's the accuracy of the scanner?
The scanner has a VDI/VDE certification, which is an international certification for non-contact measurement devices of 60 microns, so just over 2,000.
Okay, another one that we had was, how is this scanner better than the other scanners out there?
Well, what's interesting actually about that question is that there's not really a competitive scanner in the price range and value. So I wouldn't say that we're any better than any other scanner out there. We're just the only one with the price and performance at this price range. So it's kind of unique. It's really unique. It's not a typical desktop scanner, and it's not a high aerospace quality kind of high precision scanner for micron level scanning. It's great for general purpose scanning and general purpose inspection, as well as design for scan data. So it's really unique.
Well, thank you again, Scott, for answering the questions and attending this webinar. Thank you, everybody who attended. And Marlene, if you have any questions for us or you'd like to learn more about the Geomagic Capture, please feel free to contact us. You can either reach us on our website, which is www.qpluslabs.com, or give us a call at 949-380-7758. Thank you again for attending.